Now we are ready to prove first order logic of the one plus world. We still have the same situation that there is smell here, breezy here, and no breeze, no smell, no breeze, no smell. And we have the rules like for all x and y, if x is pit and adjacent x y, then breezy y. And another rule is for all x that if x is busy, then there is some y that adjacent to x and y is a pit. There are two rules here, and we have smelly, right? Smelly s at make it shorter because we have to write it many times. Okay, so smelly or s or breezy or y. Okay, smelly at location 1 2 3 1 2 3, smelly at location 1 2, and not breezy. Actually we should write breezy, bre, like this, but we have to write it many times, so we change it to not breezy at not not breezy at location 1 2, and not breezy at location 1 1, and not smelly at location 1 1, and breezy at location 2 1, and not smelly at location 2 1. Okay, so the rules is like this. Now we already done the to convert the first and second sentence into conjunctive normal form, but I think you can do it fast. For the first statement, we can do it like not pit x and not adjacent x y or breezy y. You can convert it into not pit x or not adjacent x y or breezy y. For the second one, it will be not breezy x or adjacent x and ax, and not breezy x or pit ax. Okay, so now we can use these statements combined with this to find the truth of some sentences, like the one that you want to prove. For example, because we are working with the sentence of Pete and Breezy. So we will use this part, this situation that we have to check. For example, we would like to check that this is a Pete or not. Okay. So what we have to do is, again, we can do the resolution. But this time you must add the unification and the conjunctive normal form into your system, into your algorithm. Alpha is not Pete at location 2, 2. For example, if you want to try to find this, so you have to negate it. Not alpha is Pete of location 2, 2. So guys, can you find some Pete at location 2, 2? Oh, sorry, not Pete at location 2, 2. Because your not alpha is Pete at location 2, 2. So you have to find some sentence that is the negation of Pete at location 2, 2. So you have this sentence, right? You have this sentence, right? And you have this sentence. There are 3 sentences that you can prove. 1, 2, and 3. You don't need to use the whole sentence of these, because once you have the AND operator here, you can separate this sentence and this sentence, and you can prove it later. Okay, so you have Pete, sorry, you have Pete at location 2, 2, and you have not Pete X or not adjacent X and Y or breezy Y. And then you can see that we have Pete and we have not Pete, but on the right side is an X. So you have to change, or you have to unify X to be same as L22. So you have to substitute X by L22. So the result is change X to L22 and keep Y like this. So the result is you can remove Pit L22 and not Pit X. So the remaining is not adjacent. You have to replace X by L22, right? So it will be L22 and Y, or breezy Y. You have breezy Y here, and you have not many not breezy, right? Not breezy L12, not breezy L11, but the one that you have to find is some cell or some location that is adjacent to L22. That is L12, right? So if you use the breezy Y here, and we use this one, not breezy L22. In the real world, you have to, when you write a program, but this time, because I already told you that it is a little bit complicated, so we just know the concept first to be the basic that you can apply your idea to the Prolog programming. So this time we will use not breezy L12. So it will be not breezy L12. Guys, How can we use the substitution set to be able to unify this predicate together? You have to use the substitution set, replace y by L22, right? So it can be eliminated, can be removed. So the result will be adjacent L21 and L22, right? Oh, sorry. Uh, L22 and L12, right? But you know that L12 and L22 is adjacent. So actually, there must be adjacent. May I write the shorter one? Adjacent L11, L12, adjacent L11, L21, adjacent L21, L31, and there must be a lot of these kinds of predicates. So there must be there must it must be exist in the knowledge base. So you will have for sure adjacent L22 and L12. So finally, you can do the resolution and nothing left. And if you can find that nothing left, what does it mean? It means that the original alpha, that is not pit L22, is true, right? Okay, so this is an example of the one-pass world when you apply the concept of the first order logic to this problem. So you should be able to do some other concept when you work in your software engineering field. Maybe you have a lot of rules and you would like to find the new conclusion. You have to use these things. But in the real world, if we want to write a program, we'll use the logic programming style. That is one of the very popular logic programming language is Prolog. So in the next video clip, that should be in the next session, you can study how can you write the Prolog program. This is quite long sessions, so I divide it into two sessions, so you can enjoy many concepts of Prolog, and we don't need to be hurry. So you can study by yourself. Maybe you need, I think it should be around the length of my video clip for Prolog should be around 4 to 5 hours, and you can spend one more or 2 more hours to study by yourself. Okay, guys, let's go back. Oh, sorry, let's finish this session.